Okay, so without further ado, I'd like to welcome everyone to the June monthly ReproNim webinar. We have a cycle of things that we go through monthly, and now we're back to Halchenko and the efforts of the ReproNim Technology Research and Development Core project number 3, which is about doing things. So today we will learn about version control and computation and DataLad and Repro Man and principles again. So without further ado, thank you, Jarek.
Hello, everyone. Thrilled to talk to you, although one way, but feel free to interrupt. I guess people could unmute themselves to ask questions, or I'm seeing the chat, so ask questions there as I go. So I'm Yaroslav Halchenko from Psychology and Brain Science Department at Dartmouth College. And within PBS, we established Center for Open Neuroscience. So if you want to discover more about other projects which we participate in, please go to that URL. And many of you probably already know about ReproNim project, which is Reproducible Neuroimaging Center, virtual center. We are not a single institution, but a number of institutions participating in this effort. And funding for this effort was provided by NIH as a Center for Reproducible Neuroimaging Computation. CRANC was the original name. Okay, without further information about ourselves, I'll go to the problem. So there is a problem, and I started with the same slide almost half a year ago when I talked about ReproNim. So we are quite busy these days, and then the question arises: how do we do reproducible neuroimaging efficiently? And at ReproNim, we provided 5 steps or groups of questions which touch upon various aspects of a typical neuroimaging research project. And today we'll talk about whatever is highlighted in this yellow box is about version control systems, how we could document our software and computational environments, and how could we use containerized solutions to assist us with data processing to make it, again, all reproducible. So again, back to the problem that we are still busy, and unfortunately or fortunately, there is many ways to solve the problem. There is no the solution, and that's why I use the phrase, there is more than one way to skin a cat. And in my talk, I present only one of the possible approaches. It's modular enough so pieces could be reused in different scenarios. And actually, I would invite you also to listen to our previous webinar from ReproLife. Franco Pistilli was presenting ReproLife, which is amazing centralized platform for doing computation. Well, it's decentralized in computation, but centralized as where you go to do your computation and data access. So there is multiple solutions, and I stole again part of the slide from another webinar where Dorota was presenting about how could we verify correctness of the results which we obtain within scientific workflow. But I took it as presentation of generic scientific workflow. We start with experiment, we do some theory, right? And then we perform computations. And those computations are pretty much like an equation, right? We have some inputs, we have some parameters, and we get some output. And then from those, we present our result. And to characterize any scientific workflow, I decided to come up with dimensions such as convenience, provenance, efficiency, reproducibility, and of course, correctness. But correctness was covered by Dorota, so I will not mention it again, but it's assumed, implied in all of those in any scientific workflow. Also, those dimensions are not really orthogonal. And that's what I kept saying, that convenience is actually making many things more reproducible, and efficient things also should be reproducible, because if it's not efficient, then it means that most likely you do something ad hoc. So those dimensions are not orthogonal, but it's kind of useful to characterize different solutions along them. And if I were to express them in mortal terms, what is convenience? It's just out to get it done, right? And by it, I mean computation, data collection, whatever, right? So do it and get it done. So that would be convenient if you don't need to really struggle to figure out how to do the thing. Provenance That's what have I done, right? Maybe not right away. Sometimes it's the question right after you've ran the command, you don't know what has happened, right? Um, and in general, provenance is about recovering information about the source of data or container or environment, about anything, right? So that's the aspect there. Efficiency. So whatever I've done now, do it on this data, on that data, here and there. So if that could be achieved, and also, of course, do it quickly as possible, that I would call efficient workflow, right? So when we can just do it across different scenarios and across different available resources. And reproducibility, of course, the entire center is about reproducible research, but I would say, can I or anybody do it again? And that could be, again, different levels. Could I do exactly the same experiment? Could I do exactly the same, or not exactly, but the same experiment, having the same question in mind, having the same maybe software in mind, or trying the same software. So there is different scales. Today, I'll talk about reproducibility in terms of I've obtained some results using some tool, how easy it is to reproduce them by myself or somebody else later. So the basic way we could run computation, and many of you probably familiar to one or another degree with just regular shell. It's an environment which you enter when you, let's say, SSH the remote host, or even if you're running OS X or Linux, you could just open the terminal and you end up in a shell. And it's convenient, right? At least to me. I used to, until I became 23, I've never seen shell. And then I was introduced to Linux and I was given this black box, which is a terminal, and I didn't know what to do, right? So there is, of course, learning curve, but after you mastered it, to run a computation, it's easy. You just do it, right? So you run the command. In my hypothetical scenario, it's do it with parameters and maybe providing some input and specifying where output should go. So convenient. And you could see this kind of yellow highlighted bar. It goes from the left to the right. Whenever I consider it convenient, I would make it more to the right. Provenance, though. Provenance is a problem, right? Even immediately after running that command, some people might not know, has it even succeeded, right? Because typically exit code is ignored. Typically shell scripts keep plowing, even if error happens, they could just keep crunching until the end, right? So on the vague idea, what is that doing, where it comes from, what are dependencies, we don't know, right? But also there is a good thing. Every shell has a history, and that provides, it's also really important for efficiency. I love bash history or Z shell, whatever shell history, because it allows you to navigate what you have done maybe in the past. And if you want to discover more, go to our tutorial or training materials on reproducible basics, or we point to some aspects of how to make your use of shell more efficient, but also maybe more reproducible. And reproducibility, of course, as such, in running random command in a shell is pretty much none, right? Can anybody do it again? Unlikely, because nowhere that it's recorded that, oh, you ran this command. So shell by itself doesn't, besides the history, which you don't share, which is just collection of all the commands you've ran. So reproducibility is not really a strong aspect of just running commands in a shell, right? So alone, it's not enough. So there is a problem. As kind of on this example, I could say that we kind of need to know if we are to skin the cat. We need to get a cat and then know how we get the cat somewhere where we want to have it skinned and how did we do it. And again, this is all hypothetical, no animals were hurt. So now I come to such topic as content tracking and management. And many of you could ask, what am I talking about? And actually, many of you probably know what I'm talking about. But nobody probably, or not that many people know that Git is actually, many people call it just, oh, it's a version control system. But not really. What Git says about itself is a stupid content tracker. And that's what we actually need. We need tracking of the content, so we know the provenance of the content, right? And maybe have some annotation where that content is coming from, or why it was created, or how. So among those systems for content tracking and management, I could discriminate between different layers. There are version control systems, right? That would be kind of most canonical way for Git, right? So it's version control system. Then, and bolded items are the ones which I'll cover in this talk. Git Annex, for those who haven't heard about it before, it's an addition to Git, which allows you to manage or version control large data or any arbitrarily data to that degree within Git without committing it into Git, which is really important aspect. And then DataLad is our project with Michael Hanke, in general independent from ReproNim, but it's good to reuse platforms across projects. So it's heavily used in many aspects of ReproNim projects and development. About that one, you'll hear more. Then there is another category, software distributions. There is beautiful distributions which allow you to deliver the software to the system where you need to have it ran, right? And similar to version control systems, they provide versioning information about those software pieces which you are to deploy. Some of them, like Nix or GUIX, they even use principles of version control systems as complete checksum of the entire state of the system as their driving principles. And Conda allows you also a history between changes of the environment, so you could roll back in the environment. Another project of ours with Michael Hanke is NeuroDebian, which is a distribution based on Debian, which provides targeted turnkey platform for neuroscience. And that one I'll mention, but it will not be covered in detail. And all those Linuxes become building block for many computational environments these days. Then, of course, there are virtual machines and VirtualBox as a kind of core technology, and then Vagrant, something which allows you to easier manage all those VirtualBox containers. Now it covers many other things, but it's kind of, in general, it's still virtual machine. And then, of course, there are containers, right? Containers bundle together software, data, whatever you need in the environment into one monolithic or not monolithic, how it depends how it's organized, block, which gives you immediate access to these types of environment. But in general, I would have just placed all of the systems under a single title. This is version control and distribution systems. All of them have notion of versioning, right? They have a notion of distribution. Git is inherently and used by many projects within software distributions, within containerized development and infrastructure. So all those, I've forgotten to add a figure here, pretty much are ingredients of a good cocktail for establishing really nice computational or research workflow. And that's why I would say there is no single solution, but there are different solutions which mix them in different proportions to achieve the goal of efficiency, reproducibility, and provenance. And of course, convenience, right? So let's talk a little bit more about DataLad. Once again, DataLad was initially funded by, and still funded by, NSF and BMBF as a joint international CRCNS project. And it provides you capabilities for managing your data, discovering data, consuming data, publishing data, reproducibility aspects, and which I'll cover in briefly. And to discover much more about it, Matteo, I guess this one is visible. I would encourage you to go to handbook.datalad.org, which provides a really nice resource for anybody to learn more about DataLad and start using it in your research activities. You don't need to learn everything, but even picking different aspects, there are different guides through the handbook, so really good resource. But if I were to provide a 10,000 feet overview of what DataLad is about, this would be a good schematic which was created by Michael Hanke, with whom we initially started DataLad project. So DataLad datasets, we call them datasets, they're pretty much about Git or Git Annex enhanced repositories where we contain and manage all the code, data, and metadata and containers, which we need to version control, right? And those data sets could be nested with each other, although I'll mention that aspect again in greater detail shortly. They could be nested into each other using standard Git submodule mechanism. DataLad provides on top of Git and Gitanix auxiliary functionality and kind of, we call it thin layer, which makes sometimes interactions with Git and Gitanix easier. Let's say DataLad install, or now we have also DataLad clone command. It allows you to quickly install a given data set, maybe with all the data, maybe without all the data. You could create your own data sets from scratch using DataLad create, and DataLad actually is gone. DataLad save command would have been the one to use here to save new states of your changes, which is pretty much like git commit. And then you could create new data sets using DataLad crawl extension, which would allow you to take external website and turn it into DataLad dataset. That's how many of those data sets which we share on datasets.datalad.org were born or are still being kept updated from external resources. Then you could establish siblings of a data set that's similar to Git clone functionality, but also could include Gitanix special remotes where you offload your data without sharing Git history. Then you could export your data sets to Figshare or just to a tarball to send it to somebody. And we also work, that's the part of our ongoing effort now to improve metadata management within DataLad. Okay, and talking about this nesting approach, with submodules, it's possible to create arbitrarily deep nesting, datasets nesting, where you could establish yourself a dataset, let's say for analysis, which will contain or point to, not necessarily contain in the sense that it's untouchable or undetachable component of your repository, but you could install or uninstall it upon demand. You could contain preprocessed data, which in turn could reference original bits dataset, which in turn could reference original source dataset in DICOMs. And all of that could be unambiguously versioned using Git and Gitanix. And also you could contain the entire environments, because underneath all those containers, there are just files, right? There are files for images in Docker layers. So that's what you'll hear about briefly with DataLad Container extension. So we could contain them within Gitanix repository, and also Singularity containers. They're just files, or Singularity images to that sense. They're just files which could be kept under Git and Gitanix control. And such arbitrarily nesting could be at different levels, right? So this is, let's say, example of how our all collection of all neuroimaging data at Dartmouth Brain Imaging Center is organized. It's automatically using ReproIn or QDConf and ReproIn heuristic is organized within this collection of sub-data sets. And what is kind of really nice about it is that anybody who is interested to get only those data sets which are pertinent to his or her research. Let's say Matteo was a postdoc of Maria de Gabini, PI. So Ida could take the entire collection of all the data sets. Matteo could just take the studies which he cared about. And this is just directories, right? So unlike some complicated management systems, this is all visible at the level of file systems, so anybody could figure out how to orient themselves. Okay, and now I come to the interesting aspect of YODA. Maybe some of you kind of sensed it in the title of the talk. And YODA stands for YODA's Organigram on Data Analysis, I believe. Because Matteo requested that whatever abbreviation we come up, it should be recursive. So you could discover more about YODA principles if you go to our GitHub organization and look at the poster there, which provides more details. But in general, one of the general principles is that track all input data, code, and computation environments needed to produce analysis outputs in version-controlled data sets. And reproducibility you will achieve. And it's not far from the truth, right? If everything is version-controlled, reproducibility could be maybe not easy, right? So it might not be convenient, But if you do have access to all the components and all information how things were produced, you can do it. And what DataLad is about, again, DataLad is just fulfills Yoda principles or provides mechanism to fulfill Yoda principles. So with DataLad and underlying technologies, Git and GitNX, it's easy to track everything, or in that sense, anything. Besides maybe relational databases. You don't want to put the entire database into GitNX. You could put dumps of the database though. Then we already, with this DataLad crawl and other initiatives, we amassed already 240 terabytes of neural data, which are accessible through the same unified interface of DataLad from datasets.datalad.org. Some of that data we provide, some of that data comes from actually original resources. So you might need to authenticate to it to actually get the access to the data, but you could easily navigate all those data sets and see what is contained in them. Then, as I've mentioned, with crawler, you could create your own data sets quite easily. And the beauty is that git log, the standard mechanism of Git, provides an ambiguous provenance record. And to that degree, it's Git commits, and that's what provides the record, and git log exposes it to you. And there is, of course, many more features, which I don't mention now. But I want to show you that, let's say, you could integrate DataLad within other toolkits through our command line interface or Python interface. Let's say this is example again from the same webinar from half a year ago, where I stole the slide from Mattel, which is about his study, where all those records, let's say converted subject, they were created by HudiConf while having converted the subject for a specific session, right? And then with this DataLad flag, we instructed HudiConf to make a commit, save the changes for that conversion so we have unique record. And for a user, it was quite easy. They just added --DataLad and they didn't have to worry about anything. And then let's get back again to Yoda, and I'll add just one more aspect there. If any change is computed, let's make it easy to record more provenance, right? Because typically we run a command and then we would do git commit, right? So in DataLad, we have DataLad run, which I'll mention again shortly, but also you could spot it, maybe that commit in the previous slide where there was DataLad run command. And that commit was generated by running DataLad run. And here you could see preview that, oh, it records which command was executed, what was exit code, and where it was ran. This is simplistic record, but it provides already a lot of information about, you know, how that file, which if you run git log stat, which is probably this phase diff, right? Because it added into that file, how it was changed. We have the command. We know we could actually even annotate what was input and output. So let me just go to DataLad run. So DataLad run, if you remember our initial do it command, which was do it param x and then input 1, input output 1. Now it became a little bit more complex, right? So we need to prefix it with DataLad run. Ideally, although it's recommended practice, provide what was input, what was output. That will put annotation, which later on will allow for easily rerunning the experiment. So let me just reveal all the items which I wanted to mention for DataLad run and how I kind of grade it in terms of convenience and provenance. I would say it's really convenient in comparison to just running in a shell. It's pretty much one-to-one. The extra work is needed now to ideally provide input-output specification. And again, this is just optional trade-off with efficiency later on, reproducibility and provenance. You don't have to specify them. You could just do the command and just record will not record what was the inputs, what were intended inputs to that pipeline. So if somebody needs to rerun it later on, they would know what data to get besides getting everything. Okay, so there is extra work. That's why I made it a little bit smaller. There is lots of provenance recorded now with that simple commit. In that commit, we have a record which provides information what command was ran to produce those changes. There is unambiguous versioning because of all the Git and GitNX magic. The only problem is that it lacks information about the environment, which we'll talk about later. And efficiency is also, it's not that easy. Well, there is really nice feature that content access is again made through Git and Git Annex. So that aspect of efficiency that, oh, where do I get my data, or where do I get that cat, right? That one is solved with DataLad run, especially if you annotate input and output parameters. But there is only local execution, there is no mass parallelization assistance, and no environment to share. As for reproducibility, it's actually quite great. So the only hurting factor there, again, we don't have the environment, right? So if I run DataLad run on my laptop, it's not necessarily you would be able to run it because you don't have maybe do it command, or your do it is different from my do it. So it's not necessarily will be reproducible, but with DataLad rerun, you could easily rerun one or many or entire history of your repository and compare either your results are different or the same if you run it with your do it. And it could be presented in this image which Kyle created. So DataLad run is just prefix to the command, and what it does, it records DataLad run command commit message, and then DataLad rerun, let me move this chat away. What it does, it goes through your history if you say, oh, start from this starting point, and then it reruns all the commands which were recorded, or it cherry picks any commit which is just pure git commit. And then at the end, you could verify. You could do git diff between your master and verify branch and see either it changed. Another use case for DataLad rerun is just to run DataLad rerun, and that will rerun the last commit command. So that is really nice whenever you have a script and let's say you've modified some data, you've committed it, and you just rerun that last recorded commit. Okay, if you want to know more, again, I'll just refer you to DataLad Handbook, which has other examples and more information about how to use this facility. So let's get back to DataLad run. And what did I want to say here? Probably I wanted to mention again the main shortcoming here. It's lack of environment, right? So in DataLad run, it's created specifically just make a record about the what was ran, but it doesn't have idea about the environment where it was ran. So we need to solve that problem. And how do we solve it? Of course, the best solution at the moment is containers. Again, it's just yet another content management system where the content is entire environment, right? They are usually created by a recipe, Docker file or Singularity file, and they could be reproducible. Could be, but not necessarily guaranteed. And later I'll mention tools such as ND-freeze, which allow you to better control how your tools are, how your environment is created. But also they are actually exemplars, good recipes are exemplars of great use for content distributions, because good recipe is succinct and it doesn't just install from random URLs. It just says, oh, install these packages from this distribution, either using Conda or apt-get from Debian. And they're also portable. They provide easy access to broad range of existing environments from hubs, right? So you could find random black box there and install it in a matter of seconds, right? So they could be really quick and dirty elements to bundle things together. They're isolated, which means that if you install something, you could easily uninstall it without side effects, right? So in case of Docker, it's Docker RMI or Docker RM for container. In case of Singularity, just remove the file. So the beauty also that because they're based on files as a transport, they could be kept under version control system, right? And also what was another side effect, I would say, of containerization, that they introduced or fostered, facilitated introduction of unified interfaces to the tools. It's not like tools couldn't do that before then. They could have, right? But it becomes more useful to have a container or class of containers which all have unified interface, such as BitZaps, boutiques containers, flywheel gears. But there are many disadvantages, right? I would say many praise containers as, oh, this is panacea for reproducibility, to solve reproducibility problems. No, they're really useful, but alone cannot provide complete solution, right? First of all, they're even hard to use. Quite often it's bind mounts, how do you interact with GPUs? You cannot run Docker on high performance computing. They can contain only Linux-based environments, and Singularity could run natively only on Glue Linux. And then they come without actually any guarantees from hubs where images come from. And pardon me, let me check my time. We're doing good. So whatever you've got today as your latest, right, might not be necessarily the same latest which you will get tomorrow, right? So even though they provide that information, it's not usually used. And also, there is no guarantee that that image will exist even at the same tag tomorrow, right? Hubs could disappear. And if you rely that just posting the name of the container and maybe even version, that's not a guarantee to have it available within any period of time in the future. They also might be incompatible with elderly host systems, which just have too old of a kernel. So there is some hurdle sometimes to get them running. And overall, the main problem or main kind of complaint from many is that they're black box. If you get a container, typically you don't know how it came about. You need to research into recipe which was produced, which produced it, right? Let's say Docker file. Where is that Docker file which produced that container? But even that Docker file could say from this another random image, right? So it's a rabbit hole you need to go down to figure out what is inside or how it came about. To figure out what is inside, of course, you have tools to just go inside and try to inspect. Okay, and versions of the tools could matter a lot. That's my observation with, let's say, Singularity as it progressed forward, Series 2 versus Series 3. There were lots of nuisances which you had to resolve to make the same container work again. Okay, so how would my hypothetical example of do it would look with containers? As I've mentioned, sometimes making use of them is not trivial, right? So you need to often come up with quite cumbersome specification of parameterization, right? You need to specify what should be bound, which paths should be bound from outside environment into inside environment. Maybe provide additional options for how to interact with GPUs. Maybe provide custom options. How do you make your environment isolated? In a sense, sanitize, because let's say Singularity by default bind mounts everything, well, home, TMP, passes all environment variables inside. So if you're interested in reproducibility, that would make it more difficult for somebody to reproduce if you've used maybe something from your home whenever it wasn't even intended to be used. Okay, so provenance. Again, it's kind of in the middle. There is, it's a black box. You could inspect it. You could also make it contain better provenance. I would recommend you to look into NeuroDocker, which is another ReproNim stack project, and our ND freeze to freeze Debian and NeuroDebian based images to specific date. So that allows you also to create environments. If somebody told you, oh, I've run FSL 5.0 3 years ago, right? You could figure out what, oh, it was probably NeuroDebian stretch release, and you say it's stretch and that is the date. And then you'll create an environment with FSL from that date, which is quite handy. But also you could just, when you create your own recipe, you could freeze it. You could say, okay, I'm using packages from today. What happens then, if you decide to extend that container with additional tool, you just add that line and it will install that tool from that date. So regeneration will be reproducible and extendable without compromising reproducibility of the entire environment, because tools might upgrade and you would need to pin each version, which might be infeasible. Okay, and by itself, containers, right, they don't store any provenance information about the results, right? So you need to store that information somewhere to make those containers useful for reproducibility, right? Efficiency is good, right? So we're getting there into high numbers because containers solve environment sharing and portability issue, right? So we can run containers on pretty much anywhere, right? But only locally, in the sense that you could run container on a specific compute node or a specific environment. So you need to get it to that point, right, to that location, and then run it. There is no Docker on any high performance computing infrastructure, I hope. because it's known that Docker is quite tricky to make secure. That's why people install Singularity, so it's there, it's possible. What did I mean by inconvenient? That because convenience is not really superb with all the bindings and what efficiency is also hurt, right? Reproducibility, again, unless you share all the supplemental information, nobody can reproduce it. Okay, so I would like now to welcome you to DataLad Container extension, which is amalgamation between DataLad run, which records provenance about what was ran, and containers. So now with containers extension, you could easily add any arbitrary container from, let's say, Singularity Hub. And Vanessa, I believe, is right there in chat. So if you have questions about Singularity Hub, ask Vanessa in the chat. And we will link to the container in Singularity Hub. And then you could run, execute that container, right? You could, instead of using run, the only thing we change, you would say containers run, and you would say which container, because there might be multiple available within the dataset to run it with. And otherwise, it stays the same as DataLad run. You could discover more if you go to our training materials from, let's say, workshop 2 years ago. There are examples there as well for complete workflow. Simplistic, but complete. So, DataLad container extension. Convenience, just get it done. And it works. It inherits features from DataLad run. It automatically gets all the inputs, containers, and the only thing, again, it's that you need to ideally specify explicitly what are inputs and outputs. So we are getting to high numbers there. Provenance is pretty much superb, right? We are there. We have all the information necessary or possible to kind of contain, or so we could later decipher, right? We have the environment, we have how it was ran on this data, right? So we can achieve this really nice provenance collection. It will not be in some standardized form, right? It's not like prof standard, right? But at least it contains all of it, also for humans to read, right? So you could go through your Git history and see what you've done back then, and maybe if you were good to provide your commit message, which you could specify here through -m, why you've done it, right? Efficiency is quite good, right? If you listen to Yoda, actually in Yoda, I forgotten to mention that one of Yoda principles is to be self-contained. So if within your data set, through this nesting, you have access to all the components you need, there is no bind points to specify besides these dataset binding point at top directory, right? Because then containers, data, code, everything resides within the same directory. And you have it nicely isolated and contained. And it becomes efficient as well because you don't need to specify those bind points. DataLad containers run will just bind the top dataset directory and you're all set. The problem though with efficiency, we still cannot do execution somewhere else. It's local, right? So you need to get there to execute it. Reproducibility, can I or anybody do it again? If there is DataLad run command pointing to containers, you have pretty much 90-something degree % chance that they can reproduce that commit. If, of course, your container was also internally reproducible in a sense that computation was deterministic, right? So we cannot provide guarantees over that. Although we also have a tiny project which is called NDSeed, where we list all common seed methods or environment variables, so you could seed random number generators in case you really want to achieve reproducibility, and it's possible. Okay, and I'll just go through the slides and then we'll address all the questions. Okay, and now I just want to again put another visualization of this entire hierarchy of data sets, how it could be with using DataLad and also DataLad containers. That's the vision of Yoda, that you could track at any level. You could take that tree and you have all the information necessary to reproduce the results at that level of the data set. And maybe all the way to the paper. And you could also have those components reusable. Let's say this fMRI prepped repository, right? It's used in different analyses which are used in different papers. And also you could have a distribution of containers such as DataLad Dataset with them, which we prepared, and it's called ReproNim containers, which you could reuse in different studies for different pre-processing. So what is that ReproNim containers about? It's just DataLad Dataset, which provides distribution of singularity images for popular BIDS apps, ReproNim apps, and they're semi-automatically constructed and updated, everything unambiguously versioned, images available from our copy and from Singularity Hub. Most recent version of each container is registered for DataLad Container, so you could just do DataLad Container run fMRI prep, and this is my inputs, this is outputs. It will fetch that container, it will run it, it will make the record in your DataLad Git history that it was done, right? If you want to keep it updating, but the collection, but freeze specific versions to, let's say, fMRI prep. I've used 141. I want to stick to that one. You could use a helper, which will freeze it. So during upgrades, you would need to explicitly say that, oh, for this one, you know, I want to keep it or I want to upgrade it. And then we provide also additional Singularity command shim, which has some superpowers, such as really guaranteeing that you're running execution in sanitized environment. So it runs in a fake home directory with a fake home directory, which would have only your git config file. It will run, also will assist running Singularity through Docker on non-Linux systems like OS X. I don't know if it will work on Windows. Didn't get my hands on Windows anything recently, but it should be possible to make it work there as well. And also it takes care about binding. So it makes it just easier, convenient to use, right? Also, we dedicate specific place licenses directory where you could put your, let's say, free surfer license and put it under annex. So that file then doesn't have to be shared with alone with Git, right? Because you don't want to leak your personal license, right? But the pointer to it could be there, right? So whenever you need to distribute it for computation, you could use git annex to, let's say, submit it to HPC. Okay, so this is just pretty much the same as before. DataLad containers run, but now if you include this containers subdataset as subdataset within your study dataset, you could just say, oh, it's named containers, and then there was this, let's say, container called do it. So the change is minimal. You just include containers as subdataset in your study. And the next problem we need to address is pretty much left is only local execution. If you look at all the bars here, we are getting high on the score. But with containers run, we also just do local execution and no parallelization. So I want to welcome you to Repro Man, which is reproducible manager, or manager for reproducible computation. It used to be named also NiceMan, which is neuroimaging computing environments manager, but because there is nothing really much of neuroimaging in it, we decided to reproman it, or brand it as Repro Man. And some documentation about Repro Man run is already available on Repro Man website. What it does, it sits on top of, optionally, of DataLad and DataLad container. You could use it without them. There is orchestrator which doesn't use DataLad at all, but we really recommend to use it with DataLad. And it knows about remote resources. If you can, let's say, SSH to your HPC, you could add a resource and it will get the name, let's say my HPC, right? And you could now submit your jobs with Repro Man run to be executed on that remote resource. And it supports submission of jobs also to different schedulers like PBS, Condor, Slurm, and even with support for job arrays. Or you could just say locally, which means locally on the resource you specify, not necessarily locally on your laptop, via GNU Parallel. So you don't need fancy batch scheduling system if it's just your server where you just happen to have lots of cores. There is work in progress also to make it easy just to Repro Man create your own cloud cluster with Condor and submit execution there and turn it off whenever you're done. And it's very nice to Yoda principles, kind of through the force, because by using Repro Man run on remote resource, if you violate Yoda principle somehow, your script will use something from your home directory. That stuff is not transferred anywhere remotely, right? So it will be failing, and through this kind of force, you will assure that you're adhering to Yoda principles. Currently, we are targeting specific use case. Just let's make it work nicely with Beats apps. And you could go to our pull request where it's a little bit monstrous, but it all boils down pretty much to this workflow, where on your local laptop, you could say Repro Man run. This is example of HUDconf. Next slide will show more Beats app like invocation, where you would say that, oh, run it on my resource, my Nitric, which might be somewhere in the cloud, and use DataLad pair run. So that's how we orchestrate data back and forth between local laptop and the remote resource, and specify which container to use. And then it comes regular command, and then you put it there, that you put it into the same location, and you could monitor, oh, is this job still running? And whenever it finished running, you could issue a command to fetch all the results of that execution. Because Git Annex knows which files it already has, because it's content management system at the level of the checksums, right? So it could discover, oh, this checksum I don't have yet. So it will fetch then only the results of your computation, while maybe data actually, when you submitted the job, or arrived to your compute box from original resource. You don't need even to transfer from your laptop. Let's say you're analyzing some open neural data set. It's already in the cloud, right? So DataLad get on the remote resource will just fetch it from the cloud. Whatever is not fetched, then Repro Man run will upload as well to make it complete. Okay, so it becomes a little bit more cumbersome, right? So now we need to specify which resource we need to run, which submitter to use, which orchestrator to use, but then it opens possibilities also for batch processing. So with -BP, we could create new variables such, oh, process subject 1 and 2, and then we could have job parameter that use this container, right? And then we could use these variables within our input-output specification. So here I could say, for any particular job, we need that subject from source data, right? And then the rest follows regular Beats app specification. Oh, this is my Beats dataset, which is under source data, place data in here, which is output, right? And then do it on the participant level, and participant label will be one of those parameters which we specified in the batch. So I marked it not yet high on convenience because, again, we need more documentation and there is more parameters to specify, but we are working on making it easier. Let's say we can associate what submitter and what orchestrator to use with whatever resource we are running on. And then it would be just Repro Man run on this resource. And documentation would help, and also helpers, right? So in this case, we assume that it's Beats dataset. So we could have just said, subjects use this routine, which will give me all Beats dataset subject IDs, and place it there. And then it would become more succinct and easy to use. As for provenance, it contains all the provenance you ever need. It contains instructions about, or details about job submission. It contains output logs, which DataLad run by default doesn't save, let's say, what is produced as into standard output, standard error for any specific run. But this one, it puts everything to your dataset. So you have all the information possible. Efficiency, that was the goal to solve here, right? So we are trying to solve the problem of making it more efficient to run on available computing infrastructure or initiating new one in the cloud upon demand. Reproducibility, we are getting high there because all the information is contained in such a form that it could be reused, but it's not yet convenient reuse. That's why Repro Man run is still work to be done to make it similar to DataLad run, that you could just say, oh, we do this computation maybe on this resource or maybe with these batch parameters, and then it would become kind of optimal. Okay, so we'll come to completion soon. And as a summary of many technologies which I've presented, this is our, I would say, summary slide of ReproLife of a container. And you could discover more on the poster from last year HBM. And it highlights pretty much how containers in my vision, they live, right? So we use them with DataLad Containers run. We use them with Repro Man run. There is also additional DataLad Herney extension from our collaborators from Germany on DataLad. That's their system also for automation of data conversion and post-processing. So I would advise you to have a look at DataLad Herney. And typically we create specification for either Docker or Singularity. We submit it, and that specification could be created with NeuroDocker. And this is more detailed example here, where in command line, you could create a full Docker file or Singularity file, which will first of all adhere to best practices for how to create it, so that it doesn't become 10 gigabyte big blob, right? But that all temporary files are removed. And also you could make it use ND freeze. So at the point at the top, you could say freeze it to that date, and then that container, unless you use something which without strict versioning, but if you use just apt to get packages, it will have really high guarantee to be reproducible itself. So we submit that specification to GitHub, right? Then Singularity Hub and Docker Hub pick it up and build the containers, which become available in clouds, either in Google Cloud or for Singularity, Singularity Hub, or in Docker Hub. But also we could submit images themselves. We could create them ourselves and put them under Git Annex control, right? And submit information about them into GitHub. That's what we do for our ReproNim containers. So this is pretty much the workflow. And here was also the validation. That is, I think, one of underappreciated concerns. And I would test Kraken, which Dorota was talking about in her webinar. It helps you to validate the results from running those containers, but also even running basic tests on the containers you have. That's another aspect which needs to be kind of worked through. And I want to present you also a new project which Vanessa and me work on, which is called QME. And I've mentioned that, convenience, right? We need to improve convenience. And this project hopefully will help us to make those tools more convenient to use, and also just monitor the status of what jobs you're running, when did you run it, where are the logs. And pretty much it will provide high-level web-based or terminal-based interface to see which jobs you ran and what are the outputs, and maybe also control them from this dashboard. I would advise you to visit the repository or even go through documentation. Although it's 3 weeks old, Vanessa did already a great job documenting what this QME could do. And upon that note, I just want to direct you to contribute to us, contribute and join us. And let's say for DataLad, we have public Riot Room, so join us there. There is Neurostars, where you could ask questions from the entire community. And of course, you could even get paid if you decide to have fun developing side tech with us. So there is job ad I welcome you to apply to. So thank you for your attention. And now I could get to the questions. And Vanessa already asked a question. And it wasn't private, so I could maybe read, but everybody could do it. I'm not sure how this would work with DataLad Containers run, but if it uses Singularity Cache, which will repool attack like latest and requires an internet connection, you can use this recently developed library to create a more permanent cache. This means that containers are named based on the URI, and we don't ping any registry to get updated manifest. That sounds useful. As for caching, one of the mechanisms which at least I personally underused still is mechanism within Git Annex, which we use underneath. You could establish a cache repository, which you could link to your dataset, and it will just get whatever contained in that cache. So you could establish, let's say, server-side cache where you quickly pull the data with, let's say, especially file system supports copy on write. This getting stuff from the cache becomes really, really quick. And the point also was to put the containers under Git Annex control. So if we could link it also to the different caches, now we just store Singularity Hub URL, but if we could link it to additional caches, that would improve availability and thus redundancy and resilience of your future recomputations. Okay, any more questions?
And while we wait for questions, I just want to quickly say, since we're coming up on the end of the hour, not to stop questions, but in case people have to leave, our next webinar is not on July 3rd. We're going to take that one off because it's too close to the holiday and at the end of OHBM. So our next webinar will be August 7th. Satra and the Discover team, the Describe team, will be talking about harmonizing clinical and behavioral data through Repro schema. Okay, now back to the intrepid folks on the call. If you want to unmute, there's a hand up by Alex Cohen. We can attempt to unmute and chat.
Hi, this is Alex Cohen from Boston Children's. I've been playing around with DataLad and thank you for this excellent talk. It really helped frame kind of how to use these things in best practices. One thing that wasn't on your list of trade-offs was actually performance. And that's one thing I wanted to ask about. You know, one thing I noticed, and I probably jumped the gun, I went straight to trying to use DataLad with a data set of 1,000 subjects and running FreeSurfer on all of them with Slurm. So obviously that didn't work because the DataLad tracking with DataLad run stopped after the Slurm submission job stopped, which was after 170 of the jobs had finished, but not the whole 1,000. So, but regardless of that part, which I'll still figure out, I did notice a lot of IO and a lot of slowdown in trolling the directories and with all of the symbolic links that created with the Git annex. So I wanted to understand what is the performance trade-off with using these kind of tools from a pure speed perspective, but also a data storage perspective, and how much does using Git annex really double or triple your data usage?
Yes, this is, I don't know. I am now ashamed that I didn't put that aspect on the slide somewhere. Yes, if there is trade-off, right? If you want to track, there is always some kind of trade-off. And Git initially wasn't created to, let's say, track hundreds of thousands of files, right? So if you try to stick thousands, hundreds of thousands of files into a repository, it will become slow even at Git level, even before we talk about Git annex. But we are working to make things more efficient. Let's say in your particular case, or recently, Michael Hanke, his group, they prepared Human Connectome project DataLad dataset. What that DataLad dataset is a dataset which contains 3,000 other sub-datasets, or almost 4 sub-datasets. So your jobs, let's say, submission then could say that, for this run, I need just this subject, right? And work on that data set. And that data set alone will be small. So it will become more efficient to track the result. And you will probably create per subject derived data set as well, right? So if you remember Yoda, there, if you learn about bits, it's kind of the other way around. Bits by default, although we fought it, so it's allowed now, bit says put derivative data into derivative subdirectory, right? So it's like chicken egg problem. Yeah. You are the mother, and then it's over there, which actually it used the original bits to create it. With Yoda, you do it the other way around, right? Maybe I should have not stopped sharing my screen. Let me just quickly share it again. I'll get back to that hierarchy slide, which was really informative, I would say, about this aspect. Okay, so we are here, sorry. And how do I preview? Probably cannot preview. Oh, this one, right? So here, fMRI prep dataset contains original data, bits under source data, right? So for each subject, then you could take that subject dataset and submit Slurm job to just do that sub dataset pre-processing. So you modularize your bigger collection into smaller collection of sub datasets. Then also there is, of course, aspect Git annex itself puts penalty on because it needs to checksum everything when you save the data. But that trade-off, nothing we could do about. If you want really nice version control of your data, you need to checksum it. And sometimes it becomes quite quite funny because I was doing some crawling of the data set, and I thought it will be faster if I just do it in the cloud, because the original data was also in S3 bucket. But files were so big, I don't remember how many gigabytes, so they wouldn't fit into the memory. So checksumming was taking longer than actually to download the data, right? But when we discover such use cases, we don't stay silent as well. We talk to Joey, who is the author of GitAnnex, and we come up with the solutions. So GitAnnex becomes more proficient, I would say, as we go through time. DataLad becomes also more proficient as we discover how we address these maybe performance penalties or trades-off. More we use it, better it becomes. Let's put it this way. More other people use it, it becomes even better because people provide their independent feedback. So
I don't want to get into the weeds too much, but in those kind of situations from a principal standpoint, where does the re-executability get stored? Does it get stored in the overall, because if you're running the execution at the whole data set level, but only providing the, like, are you just providing the subject data set as an input, or do you actually run or do you do DataLad run at the subject level, and so it gets stored at a, so how do you create your hierarchical data sets to make sure that you've got the provenance stored in the right places?
Yes. Again, great question. Again, many ways to skin the cat. I would recommend you take each subject data set. Let's say, imagine these bits, fMRI prep. It's just that particular. If you have so many subjects, let's put it this way. If your data set is specific, let's say there is views now of human connectome project anatomical data set. That one itself doesn't have that many files. It could be the entire data set, right? Then you could modularize also that way. You create different views of something bigger, which is particularly fit for specific use case. And you could look into handbook. There is a whole section on HCP. So how to manage these really large collections. Hopefully it provides better, maybe even answers than I just gave here. But all the information about how these data in particular data set came about, it should be contained or reachable from that data set. By reachable, I mean the sub data sets would have information about themselves, right? And then parent data set, fMRI prep, would know I've ran this command to get myself, and it was based on this bits sub data set, which I got from there, and it was this particular version.
Thank you. I'll see if anyone else has questions.
Yes, and thank you for that question. And of course, we can discuss further offline and in Cyberland until we can see you in person someday. Any other questions out there in Radioland today?
I've got one.
Excellent.
If nobody else has jumped in. It kind of follows off of Alexander's. So it almost sounds like this is a way to kind of encapsulate sort of finished pipelines. I mean, pipelines meaning the entire process, because I'm trying to envision how, oh, I want to try this kind of way of redoing a GLM. Oh, I want to try this kind of way of redoing the GLM. So you get this branching style, and it seems like having all of those different branches would just muck everything up. Am I right that you see this being done kind of at the very end, sort of, when you're in production mode?
Yes, no, maybe. Again, many ways to skin the cat. And as for branching, many people actually use Git specifically for that purpose. Oh, I want to try with this parameter. So they branch out into, oh, it's running this particular parameterization of the workflow, right? So then you have your branches and you could compare and decide, oh, I'll merge this one, right? So it might be purposeful to do this branching. Then actually what I was started to scroll for, you don't have to wait for, oh, I have the pipeline. Where was it? Here we go. So I started to run even SED, like SED, command line tool, through DataLad run. Because then I have a record how the heck I did it. And if I need to do the same type of fix again, I would just DataLad rerun that commit, and it will fix the typo again in the new text. So these tools are available at any level. It could be huge pipeline, because this is, again, it's not workflow manager, right? So if you have a workflow, let's say you have your NiPipe workflow, which is what fMRI prep, how it is done, how MRI QC done, then you could just give, it's this block, right? It's in this container, it's this block, and then DataLad would just record what happened from before until it was finished. Meanwhile, it might also record a proper provenance record. I know NiPipe could export prof graph, right? So in that commit, then you'll even contain really detailed information about getting deep into the weeds if you really want. So could be used at any level. I use it for anything, on bread and butter.
And one of the advantages of using it in that sort of garden path that you sometimes take to develop the analysis is, you try a bunch of things, and getting back to the thing that worked right is sometimes, complex, especially depending on what your notes are. So it's a good way to, in the end, prune your garden path into the path that you actually want.
That's exactly what I asked one of students I'm working with, because he was using DataLad run and containers run, but then at the end, history would be, it's like with Git history, it will be as nice as you make it nice, right? So if you used absolute paths in your execution, DataLad run will just swallow it, because we don't know what those paths are about. So at the end, you might come back, and based on that dirty log of what you've done, you could go and kind of, okay, I've experimented here. This is not needed, right? So I just do this command, I just do that command, and you could create a really nice lean view of history in your study. Actually, there was a recent interview with Junior, the main maintainer of Git. And I really liked one quote, which I didn't remember word to word, but when he was asked, like, what is the main feature of Git? I thought it would be about distributive and whatnot, but he said that main feature, maybe, or property, is that it let good programmers become or look like great programmers. Because you could create these dirty commits, and then when you're done with whatever changes you wanted, you could rewrite the entire history, provide good annotation, and make it really nicely modularized. So the same principles apply here.
Great, thanks for the question. So with that, why don't I thank everyone for attending. It was great attendance, and thank you, Yark, a tour de force as always. And again, the last reminder that there will not be a July 3rd presentation, but we will resume August 7th with Satra and harmonizing clinical and behavioral data collection. So thank you all, and see you out there. Reproduce safely.